In this video, we're going to solve a form of quadratic problem called a rectangular area problem. Before you can successfully do this, you really need the skill of solving quadratic equations. So you really need that skill first. This video will just cover how to apply a quadratic equation to a rectangular area problem. So to solve a rectangular area problem, you need to be very clear about your length and width. So make sure you label them clearly in your on your paper, on your notes. But unfortunately, if you have two unknowns, let's say you don't know the length and width, you really need the equation to only have one variable in it. And this is really important. When you solve a quadratic equation, you really only want one variable in your equation. And then you can solve the equation, but you may need to multiply first. Oftentimes, your equation will not look like a quadratic equation until you multiply, and then you'll see you'll have a squared term. So let's take a look at an example. Now, I'm recording this on a laptop with a webcam, and the webcam is not designed to focus closely, so this may be a little blurry, but we'll read it out loud. The length of a rectangle is 4 centimeters more than the width. The area is 96 square centimeters. Find the dimensions of the rectangle. Well, here it says the length is 4 centimeters more than the width. Now the width, we can just have W. So please notice that both my quantities, length and width, are expressed in terms of W. It also says that the area is 96. So if you remember from geometry, the area of a rectangle, A equals LW, length times width. Now we're just going to plug in, here's my length, and here's my width. So let's write the equation. Oh, and here's the area, 96. 96, which is the area, equals, now my length is this quantity, 4 plus W, and my width is just the letter W. Now remember what I said before, you need to write an equation with only one variable in it. And it doesn't look like a quadratic, so we will probably need to multiply first. 96 equals 4W plus W squared. This is a quadratic equation which you must solve. Let's just rearrange these terms a little bit. W squared plus 4W minus 96 equals 0. And now we're going to solve this quadratic. This is a simple trinomial. So we're going to have W. The product is negative 96. So we're going to have a positive value and a negative value. And the sum is a positive 4. So the positive value is going to be slightly bigger. So let's factor 96. Just to see what pairs of numbers we're going to have. Obviously it's 1 times 96. 2 times, well, half of 96 is 45 plus 3. That's 48. 3 goes into 96 32 times. 4 goes into 96, doing long division in my head. 4 goes into 96 28 times. Now, so far, are we going to add up to something that gets to 4? We need to keep going with this. 5 does not go in. 6, does 6 go in? No. 7, 8. 8 goes into 96. That's 12 times. And I hope you see the difference between 8 and 12 is 4. So what if we were to have a larger positive and a smaller negative? To form a product of negative 96, we could have put positives and negatives in here. So this really is the one we want. We're going to stop here. So we have a W minus 8 and a W plus 12. And just real quick, do FOIL in your head to make sure that you actually have factored that correctly. Here we're going to get W equals negative 12, or W equals 8. Now, getting back to the original problem, it's talking about the length and width of a rectangle, and the width of the rectangle is W. Does it make any sense that the width could be negative 12? No. So we're going to just ignore this answer. This doesn't make any sense. So this is really the best answer for the width. But now, again, go back to the original problem. It doesn't say find the width. It says find the dimensions. Now we found the width. Now what's the length? 4 plus the width. So the width is 8. The width is 8, and the length is 4 plus the width, which would be 12. And that. Okay, let's solve another problem. In this problem, it's a little more complicated. We have an area rug in the middle of a room. It says a 4 meter by 6 meter rug covers half the floor area of a room and leaves a uniform strip of bare floor around the edges. What are the dimensions of the room? Now remember, to solve these, we're going to first label our length and width clearly. We're going to have our two unknowns, but we're going to have to write the equation with one variable, and we're going to solve the quadratic equation. So this one's a little tricky, but they helped us out with this drawing by having x and x. I hope you realize that this one over here is going to be x, and this is x as well. So we have the rug. The rug is 4 by 6, but the room, the length of the room, you consider 6 to be the length. The length is 6 plus, we have x over here and x over here. If this is the length, 6 plus 2x. The width of the room, if you consider 4 to be the width of the rug, we have 2 strips of bare floor, so it's 4 plus 2x. That's the room. Now what else do they tell us? That the rug is covering half of the area. So if this were the room's area, and then we have the rug in the middle, the rug's area is half of that. Now what's the rug's area? 4 by 6 is 24 square meters, so the room's area has to be twice that. The room's area must be 48 square meters. So now we have enough information to solve this problem. We have the dimensions of the room, length and width of the room. We also have the area of the room. Okay? Notice that I'm clearly labeling everything room area. All right? Room area and the length and the width. So now we're going to write our equation. Length times width, and I'm going to just reverse this because it's easier to look at. 2x plus 6 times the quantity, 2x plus 4, equals the area of the room, which is 48 square meters. All right? Now again, when we are solving these, we've labeled things, we've written an equation with one variable, and now we have to solve the quadratic equation, but we may need to multiply first. So we're going to multiply this. Now, I will say this, if you're, if you recognize factors, you may see that we can cancel out a factor of 2, a factor of 2, and a factor of 4. But I'll leave that to the more advanced students. Right now, we're just going to use FOIL, F-O-I-L. So we have 4x squared is f, 2x times 4 is 8x, 2x times 6 is a 12x, and then 6 times 4 is a 24. And this equals 48. Now we have to solve, well, we'll combine like terms, but we also have to subtract 48 from both sides to get it to equal 0. 4x squared plus 8x plus 12x is 20x. And here I'm just going to do another step. I'm going to subtract 48 from both sides. This is going to give me a negative 24 equals 0. We're now going to use the zero product rule. Well, we can't use it right away, but the point behind solving this for 0 or setting it equal to 0 is to factor this polynomial. Now, one of the most important factoring techniques is to factor out a GCF. And here the GCF is 4. So 4 times the quantity, x squared plus 5x minus 6. And now we can continue our factoring. 4 times the quantity of two binomials. And I hope you see that if that's a negative 6 and that's a plus 5, what times what is negative 6 but adds up to 5? That would be a plus 6 and a negative 1. Now, using the zero product rule, we have x plus 6 equals 0 or x minus 1 equals 0. So x can either equal negative 6 or x can equal 1. But if you go back to the original problem, does negative 6 make sense? Negative 6 cannot be the length of the bare strip. So the actual answer is this, and it says, what are the dimensions of the room? In other words, they didn't ask us for x. What are the dimensions of the room? Well, now that we know that x equals 1, the length of the room is going to be 6 plus 2, which is 8. The width of the room is 4 plus 2, which is 6. So the room is 6 by 8 meters. Final answer.